When we talk about aircraft manufacturing, we're describing a massive engineered flow that turns raw materials and computer designs into flying aircraft that carry millions of passengers every day. It isn't one machine making one part. It's hundreds of processes happening in harmony, from cutting and shaping jobs to assembly lines, inspections, painting, and testing. At its heart, aircraft manufacturing is a blend of engineering precision, production discipline, and coordinated teamwork that makes safe flying possible. Aircraft start life as big chunks of aluminum, titanium, composites, and engines, then are progressively transformed into parts and structures. Raw materials are processed into components. Parts are assembled into subassemblies like wings and fuselage sections, and these major sections finally come together on the final assembly line to form the complete aircraft. Every step adds value, from forging and machining to joining and system integration, before the plane rolls out for testing and delivery. Part manufacturing is the cutting, shaping, drilling, and machining of individual pieces. Subassembly joins those pieces into larger structures like wing boxes, fuselage barrels, or landing gear modules. And final assembly is where those subassemblies are brought together into the complete airplane. Think of it like LEGO. The bricks are parts, the mini builds are subassemblies, and the full model is the finished aircraft. Each level needs its own checks, tooling, and sequencing to make sure things fit and function right. Modern aircraft are global products. OEMs like Airbus and Boeing rely on thousands of suppliers around the world that make the majority of parts and subassemblies before they even reach the final assembly line. Some sites manufacture composite fuselages, others make wing ribs or avionics, and others build engines. Then everything is shipped and coordinated so it arrives on schedule. This global network keeps costs down and expertise high, but it also demands world-class logistics and quality control to make sure every piece fits when the time comes. Assembly sequencing is like choreography for machines. It defines what gets built first, next, and last, so parts don't get in each other's way. Smart sequencing makes sure structure comes together in the right order, systems can be installed without conflict, and tools and people can reach where they need to be. Effective sequencing helps reduce rework and delays, and it ties into inventory strategies like just-in-time delivery, where parts arrive exactly when they're needed, not weeks early or too late. Every stage of aircraft production has quality gates, from first article inspections of raw parts to dimensional verification of critical assemblies and final system tests before release. Advanced inspection methods like coordinate measurement machines, ultrasonic scans, and visual checks ensure that each part not only matches its CAD design, but also meets safety and reliability standards. These checks are documented and traceable. You can't just build it. You have to prove you built it right. Design requirements don't stay in engineering. They flow down into every step of the production process. That means drawings, tolerances, tooling instructions, inspection criteria, and quality plans must all reflect the original design intent. From a raw billet to a finished wing, every operation must be aligned back to the spec so the final airplane reflects what engineers intended, regulators approve, and customers expect. This flow-down ensures conformity, safety, and traceability across the whole manufacturing system. This flowchart shows two main parts of aircraft production: manufacturing and assembly. Manufacturing is where individual parts are made from raw materials using processes like casting, forging, machining, sheet metal forming, and composite manufacturing. These processes shape the material into usable aircraft components. Assembly methods are used to join those parts together using techniques like riveting, bolting, welding, and adhesive bonding. In simple terms, manufacturing makes the parts, and assembly connects them to build the aircraft structure.